Students, will start with the next topic, that is kinetic energy. Okay, we can all just go through these two activities. Okay, I'll start from this here, that a moving object can do work, that we have seen already, and the object that is moving faster will do more work than the same object which is moving with relatively slow speed. So if you have got more speed, the work done will be more, and if you have got slow speed, then the work done will be less. This all we know, and these are some examples of the work done with a speed. Okay, now the objects in motion, they possess energy. Obviously they have to possess energy, otherwise how the work will be done. Okay, so all of them possess energy. Now this energy which is possessed by the objects in motion is called as kinetic energy. So any moving object, energy possessed by that object is called as kinetic energy. The examples are given here. All these objects, they possess kinetic energy. Okay, now kinetic energy is the energy possessed by an object due to its motion, that is due to its movement. The kinetic energy of an object increases with its speed. So more the speed, more the kinetic energy. Okay, now how much kinetic energy is possessed by a moving body by the virtue of its motion? For that we will have to see a equation. On the next page, the kinetic energy of a moving object in form of an equation. Let us see that. Now suppose the mass of the object is m, velocity is u, and distance is s. Okay, now we know that force F is acting on it. Okay, and the displacement done is by distance s. So work done will be W is equal to F into S. This we all know. We have studied this previously, that work done W is equal to force into displacement. Okay, now velocity changes from u to v, that is initial velocity u and final velocity is v, and then you have acceleration produced. You know what is acceleration? That is v square minus u square upon t, that is acceleration. Okay, now if the uniform acceleration is there and we have got final velocity and initial velocity u and v, we have studied this equation, that v square minus u square is equal to 2as, where s is the displacement, a is the acceleration, u is the initial velocity, and v is the final velocity. Okay, now from this equation we get, keeping s on this side and taking all other on 2a on this side, we get v square minus u square is upon 2a. When we are taking 2a here, okay, we get v square minus u square upon 2a. So this is the formula of s. Now we know that formula of f is equal to m into a. So we have got S and we have got F here. Okay, so now W is equal to F into S, that we know. Now F is equal to MA and S is equal to V square minus U square upon 2A from this. Okay, so we have substituted this here. Now when we cancel this, A and A gets cancelled. Okay, so what we get is half M v square minus u square. So W is equal to half m v square minus u square. Now if the body is starting from a stationary position, then the u becomes 0. Now when u becomes 0, you have got half m v square, because u has become 0. Okay, so if u is 0, it will become half mv square. So this is the equation for kinetic energy, that is kinetic energy Ek is equal to half mv square. So this is the equation for kinetic energy. Okay, now we have got example 11.3. Here the object of 15 kg is moving with velocity 4 meter per second, and you have to find the kinetic energy. 15 kg is the mass and 4 meter per second is the velocity. You just have to put it in the equation. Okay, now in the equation, half into 15 kg into 4 meter per second square, okay, is equal to 15 meter into 4 meter per, because it's v square, so you have to multiply 4 2 times, so you will get 120 joules.